Alright, this is section 8.3 and we're going to do this a little differently. We're actually doing it in school and we'll see how this works. This section is on bouncing, and you probably don't think too much about bouncing. We're not talking about bouncing like bouncing a ball. We're talking about catching something and then throwing it back again. But the main point of this is the impulse required to bring an object to a stop and then to throw it back again is greater than the impulse required merely to bring it to a stop. Suppose you catch a falling object with your hands and you provide an impulse to reduce its momentum to 0. And then let's say you throw it back up. Well, then you have to provide an additional impulse. Remember, you're bringing the momentum to 0 and then you're throwing it back up again, so you're giving it more momentum except in the opposite direction. And I think a good example of this is when a volleyball player sets the ball. They're basically stopping the ball and then sending it right back up. And they're now, here's the way I always think of it is, what if something falls on your head? And if you have a, say a flower pot fall on your head, you want it to hit your head and then break. You don't want it to bounce. If the object bounces off your head, which you don't want, it's going to lose its momentum on your head and then bounce off your head. It's going to gain momentum again. So that actually is more force, which means more force on your head. So and that increase in impulse has got to be supplied by your head, so it's gonna hurt. One of the places where people use bouncing is in martial arts, and what they do is they hit the object and then the hand sort of bounces off the object that they're trying to break, and that yields twice as much of the impulse to the object they're trying to break than if they just tried to hit it. This is a demonstration that you see all the time, and I'll show you guys a film of it. Is if you take a dart and you hit it with a wood block with a dart that has a spike in it, the block will not topple. But if you hit that same block with a rubber dart so that the swinging dart bounces off of it, the block will fall over because it gets twice the impulse on it. And here's another picture of the demonstration. In the first one right here, they hit the block with the wooden block is hit with a dart, but the dart doesn't have any rubber tip on it. Here the dart has a rubber tip, and when the dart bounces out off the block, it knocks the block over. Once again, same thing. Metal bullet hits a block, it penetrates the block doesn't fall over. In this case, it's a rubber bullet. The rubber bullet hits the block, and the block actually bounces. The rubber bullet bounces off the block. The block will then fall over because there's a greater change in momentum, because not only the bullet hits it, but it also bounces back off. This is called a Pelton wheel, and they were used during the gold rush out in California. And what the idea behind it is, rather than just have the water hit a flat paddle to make the wheel turn, they made the wheel with little bowls, and these little bowls, the water would hit the bowl, pushing it down, and then the water would bounce back out, which would increase the amount of impulse on the wheel, causing the wheel to turn more effectively. So the water effectively bounced. One of the things I'll show you is bottles breaking over your head videos, and you can look at those on YouTube. But basically the gist behind that is, if you watch the two videos, you'll either see where they're successful or they're unsuccessful. When they're successful and the bottle breaks, the person usually is still standing and doesn't really feel any ill effects of being hit over the head with a bottle. If the bottle doesn't break over the head, you're going to see the person probably fall to the ground in pain because the bottle bounced off their head, thus larger impulse, which means a larger force off their head. So how does the impulse of a bounce compare to stopping only? Well, we know it's greater than, because the because the object has to stop and then go back again. So that must require a greater impulse than just merely having the object stop.